Hi guys, in class we've been talking about inertia, and inertia basically states that an object at rest wants to stay at rest and an object at motion wants to stay at motion. And what I made was an inertia hat. All it is a coat hanger that I bent and twisted and some Play-Doh jars. So I'm going to gently set it right on my head. I'll stand back a little bit so you can see it. So right now, for the most part, the Play-Doh jars are at rest. There's a little bit of movement because when I sway a little bit, when I try to stand still, my mouth is moving like that. But right now, the inertia is trying to keep it as steady as possible. Now I'm going to change the inertia, but I'm going to give a light push of an outside force, and they're spinning. And they're going to want to spin until they fall off my head. Try it again here. A gentle outside force. Now there's friction happening at the top of my head. It wants to move until that friction wears out. So what I'm going to try and do next is I'm going to spin and see what happens to the Play-Doh jars. It might fall, it might not. Let's see. So I'm going to turn very slowly. They didn't move as much because I didn't apply much of a force. They moved a little bit, but if I try to spin again, they're not going to move nearly as fast or as much as if I hit it with my hand. So I'm going slow so I don't knock it over. My head's not flat enough, I guess. And then watch again, if I use an outside force, they definitely move quicker that way. Next I'm going to show you how I made the inertia hat so you can try and make it at home too. Alright, to make your own inertia hat, basically I took a cheap hanger, I think maybe from a dry cleaner, and what I'm going to do is I'm going to untwist it the best I can. It always seems like I can do it easier when the camera's not on, but that's okay. And the goal is to try and get it as straight as possible. Your inertia hat will work better and it'll be easier to make. So I'm going to try and twist it the best I can into a straight line. The first one I made, it took about 20 minutes or so to get it all straightened out and working. So it does take a little bit of patience. But if you're at home and you have some time to kill, this is the perfect activity. So it's getting pretty straight so far, just a little bit over here. Now for the sake of my display, this might have to be good enough. But you get the point. As straight as it can. You could even use a pair of pliers if you wanted to pinch it down and keep it straight. Like this. So it's about, might be about as good as I can get it for now. So to make it, I'm going to turn it so that it's basically in half. And then I'm going to squeeze this part closed here. So essentially it's in half like this. Straighten it out as much as I can. So I'm going to make it into basically a letter M, and I'm going to start twisting one side down twist the other side down. And the key being that the part that comes down here needs to be lower than this middle part. I'm trying to keep it even on both sides. And I found that if I stretched it out, it worked better because I don't want to hit my shoulders as it spins around. And what you can do when you make yours is kind of test it out on your hand to see if it will balance or not. I also tried it in front of the mirror and stuck it on my head to see how that worked. But I think the hand is a little bit quicker instead of running to the mirror the whole time. Plus that way you don't take up the bathroom. So I'm going to hold it here. It seems like it's tilting backwards towards me. So I have to make little adjustments. And even the smallest tweak or change can make a big difference. I'm just trying to see how it balances. And the one version that worked better for me was my B in the middle here was stretched out. I tended to have more success that way. Test it out with my hand. So it seems like it's balanced, but it's kind of tilted towards me still. So I need to make another adjustment so that it's not laying flat like this. It's a little better. So like I said, it takes patience to make your inertia hat. And when I actually got it to work, I put it on my head and I kind of just stretched it a little bit to see if it would work there. Almost. So it takes time, but my finished product that I made before looked like that, like it was this stretched out, and then I sat it on my head. No, it's not going to work, we'll see. Like that. And it's very rewarding when you get it to work. For the ends of the inertia hat, I chose to do Play-Doh. Some people have used tennis balls, even like the foam craft balls, but I heard that they were too light, so it was easier on your head, but it didn't balance as well. What I did with my little Play-Doh containers, as I said earlier, I think I weighed them. So I have a little digital scale that I use to measure coffee. And what I did, let me see if I can move this down, is I basically weighed it. This looks like it's 33.6. .9. So the beauty with Play-Doh is what I could do is take some out or put some in as needed. Now I don't know how sensitive you want to get to it, but if you use tennis balls, the thought is they're going to be basically the same. Play-Doh, you can kind of change the weight back and forth. Now when we're talking about inertia, mass matters. The amount of weight that an object has is important. So I have 3 containers here. This shaker's empty. This container has about half filled full of water, and this one is completely full. It is the heaviest. Now when I flick them, I'm going to try and flick them with the same amount of force. I want you to see what happens. That completely fell off. Mini cabinet type. Let's see what this one does. It moved a little bit. That one barely. Kind of destroyed my finger. And the reason being that this one has the most inertia. It's got the most weight. This one had a little bit less, and the empty one totally fell off the countertop a couple of times. So with this next experiment, I have the one container with no water in it, half the water in it, and completely full. What I'm going to do is I'm going to quickly pull this bandana as quick as I can, and I want to see what happens. Which one will fall? Will one stay the same? Let's see, so I'm going to try and do it as quick as I can. Oh, it looks like the light and the half full fell over, but the heavy one did not because it had more inertia in it. Let's try it again. All right, remember we've got heavy, medium, and lightest. Let's see what happens when I pull it. All right, that time, just the light one fell over, and the medium amount and the heavy amount stayed the same because they had more inertia than the container that had nothing in there. All right, guess who's here? Abram and Benji. They want to see the experiment too. So, we have the empty one, the one that's halfway full,
and that one's full.
and it's full. Feel how heavy it is.
It's heavy.
Very heavy. You want to try it? Very heavy, very heavy. Okay. Now, the heaviest one has the most inertia. This has half the amount of inertia or weight, and this one has the least.
There's no
So
water.
what I'm going to do, did you ever see those things where people on TV pull the
No,
tablecloth
I did
out?
not
You've never
see-
seen that before?
No, I'm
We're
scared.
gonna see it
I'm
now.
scared.
So here's the deal. I have to pull it super fast. Which one do you think is gonna fall?
The heavy one.
You think the heavy one. What do you think?
The heavy one.
You think the heavy one will fall? Maybe they'll all fall.
Yeah.
Do you think any of them are gonna stay standing?
I think that one.
The light one you think is gonna stay?
I think this one.
Okay. I've done it a couple of times and it's been different almost every time. Let's see. So the key is to pull it really fast and not to elbow Benji in the face or anything like that. So let's see. 1, 2, 3. Which one fell?
This one.
The light one. Because it had the least amount of inertia.
I won. I thought you were gonna pull it and they were all gonna crash and bang on.
Oh, sorry. For our next experiment, I have a plastic cup, a plate, a paper towel roll that I cut in half, because I didn't have any toilet paper rolls. And I've got a Play-Doh container. And I'm just going to set it up top like this. So the law of inertia states that any object at rest wants to remain at rest. Is the Play-Doh container standing still here, guys? Is it moving?
No, it's
No,
not
it's
moving
not.
because no one's touching it.
So my thought is, what if I quickly pull this plate out from underneath it? What do you think is going to happen to the Play-Doh
I
container?
think it's gonna fall right into the cup.
Okay, that's what
think
you think?
And I think that's gonna fall.
Okay. You think that's going to fall in the cup also?
that's gonna fall in the cup.
Alright, so I'm going to pull it as quickly as I can, and then I'll give you guys turns and you can pull it. And we'll see what happens.
mine's not gonna fall. I'm just gonna fall in that cup.
Alright, 1, 2, 3. It went right in, right in.
No, I don't want it. No, I haven't.
There's a little bit of water. Benji, you want to go next?
Yeah, that sounds Can we put water in mine?
I don't know. We have a little bit of water on the plate. So we're going to flip it right like that.
I need it a little bit closer.
I'll get you closer.
Of course you will.
Let's move you closer here. And we'll count to 3. And what I need you to do, Benj, is pull that plate out.
Okay.
You gotta do it real fast. 1, 2, 3. Oh, not fast enough. Let's see if Abram can do it. Okay.
I can go a little too fast.
This.
I need to go closer.
Okay, we'll get you closer.
Hi guys, it's Abram. Bye bye.
All right, watch your head in case Play-Doh hits it.
All
All right, good job. Benji, you want to try one more time?
Uh-huh.
All right, hop down.
Oh,
Cool. And you have to pull it super fast.
I can pull it.
Yeah, like that. Let's see. Ready? 1, 2, 3. Almost.
Where did the Play-Doh go? I'm getting the Play-Doh. Is that too fast?
Maybe it was just too fast to handle. All right, so let's review. We were talking about inertia and how when an object is at rest, it wants to remain at rest unless an outside force knocks it off. The experiment that we just did, excuse me, we have our cup and our plate
And the Play-Doh.
and the paper towel roll wet where?
I'll go get it.
Okay, you'll get it. We're gonna set it right like that. Carefully get the paper towel roll.
It's then we put it on paper.
Right here.
And we
Just wait, just wait. So if I applied force to the Play-Doh, if you wait, you can do it. Okay. If I just apply force to the Play-Doh, then the Play-Doh will fly away. Like that.
This fell too.
But
we have
if we apply force to the plate, if our outside force is to the plate, I think we can get the Play-Doh to fall right inside the cup. Now I'm going to do it first, then I'll let Benji do it, alright?
Yeah. Well, this pumpkin.
So the key is to do it super, super quick. We hit the board. Alright. Alright. 1, 2, 3. Ooh, I got both in. So pull it real quick like that. So the inertia of the Play-Doh wanted to remain still, but because I pulled it so quick, it had nowhere else to go but to land right in the cup. Now Benji wanted to give it a go.
This time we're gonna go boop. Okay. Oh my God. Okay.
Alright, 1, 2, 3.
Oh!
He did it! Good job!
I
Good
saw it
job!
did like a flip or something. So why does the paper towel always go to this?
And we should try and see if we can get a slow-mo shot of this too.
I am.
Pull it here.
Doo, doo,
Yes.
doo. Wait.
Chances are you've experienced inertia and you didn't even realize.
And no one's
So-
driving the car.
If you push the gas pedal and do a power boost like our boys like to call it, right Benji? That means the car will go faster.
Yes.
So you guys ready to do a power boost? Are you ready, Abram?
Yes, I can reach it.
Okay. Power boost. Oh, do you feel it?
I feel it.
You going back in your chair?
Yes, I feel it a lot.
Okay. Mommy, make a turn when you can. And if they make a sharp turn, you might turn in your seat. All right, here it comes. Get ready.
I'm kind of scared.
Whoa.
I thought the turn would be another way, but it went the other way. I was prepared this way, not this way.
And of course I have my seatbelt on during this whole time. And then if we stop suddenly, you'll go forward. Whoa!
Why didn't my buckle catch me? It always does.
That's a question for GM.
I want another turn. I want
So when the car is moving forward and then all of a sudden has to stop, that's inertia. Your body wants to stay in one place, but the car, the force of it, pushes you forward or pushes you backwards if you're going really fast.
It goes like this. I still walk it. Where? Right there.
All right, we're ready for a turn. We're gonna do a sharp, hard turn. Watch Benji in his seat.
I almost touched
Whoa!
my window.
Is Kit doing okay down there?
Yes, he is.
See a little Kit Cam right here,
Yes.
chilling in his moccasins.
And we're going to Reagan's house.
Oh, cool.